Hi guys, today's August 28th and we're going to go ahead and get started on section 1-3, solving equations. Hopefully by the end of the lesson, you'll be able to use the distributive property to help you solve. Let's get started. Looking at example 1, we're going to start with the distributive property as our first step. To distribute means to multiply to everything inside the parentheses. So I'm multiplying negative 7 to negative 6 and also to 8n. So negative times negative would give me positive 42. And then negative 7 times 8 would give me minus 56n. Everything else, I'm going to just make sure to go ahead and bring it down or to rewrite it as it's written. So negative 16 plus 5n equals what we already had plus 3. So remember, our ultimate goal in solving equations is to isolate the variable or to get the variable alone on one side of the equal sign. So in order to do that, let's make our job a little bit easier by combining like terms. Like terms have the same variable, and if I notice on this side of the equal sign, 42 and 3, they don't have a variable. That's called a constant if it doesn't have a variable. So we're going to combine those together. I'm going to combine 42 and 3 together to get 45. And then again, let's bring everything else down. I'm just going to rewrite everything else. I'm going to just keep that in black. Negative 16 plus 5n equals 45 minus 56n. You might be thinking, hey, where did the 3 go? Remember, we combined it with the 42 and we have 45. So you don't have to worry about the 3 anymore. So from there, remember our ultimate goal, get the variable alone. So let's go ahead and start by getting the variable on one side of the equal sign. I typically like to move the smaller variable, which in this case is negative 56n. And whenever I say move, you can't just move it. You have to do what's called the inverse operation. So the inverse of subtracting 56n is to add 56n. And when I do that, the 56n will cancel on this side, and I moved it over here, and it's going to combine with that positive 5n. So, sorry, this is going to be plus because the inverse of subtracting would be to add. So let's go ahead and add those together, and I will get 61n. Again, everything else, bring it down. So negative 16 plus 61n equals 45. Let's finish it up by getting closer to isolating that n. The opposite of subtracting 16 is to add 16. So I have 61n equals 61. Ultimate goal, get n alone. So in order to do that, right now this is really multiplication. Even though we don't typically write the multiplication symbol in between, the inverse of multiplying 61 times n is to divide by 61. So they would cancel each other. And so n is equal to 1. When I speak with you again, I'll show you how to check your answer to make sure it's actually right. Let's look at problem 2, and if I notice this one, again, I see a set of parentheses with a number outside, so that means I'm going to distribute, use that distributive property again. So 10 times p, 10p, and 10 times 10 is 100, it's positive. And let's talk really quickly on the side, how do I multiply fractions? Well, let's see, negative 5 over 2 times 2p, or let's just talk about the 2 for now. So I'm going to multiply by 2 over 1. When you multiply fractions, it's just the numerator times the numerator, denominator times denominator. So negative 5 times 2 is negative 10 over 2 times 1 would give me 2. And then I simplify that to get negative 5. So this, when I distribute, I'd get negative 5p. And let's go ahead and distribute negative 5 over 2 times 12. 5 over 2 times 12, and I could say 12 over 1 if I want to, and top times top, I'd get negative 60 over 2, which is negative 30. So if you forgot how to multiply fractions, there's a quick mini side lesson, but what we can't forget is to bring down the other numbers that were involved in our equation. So I have negative 11 plus 10p plus 100 equals 4 minus 5p minus 30. Again, we're basically going to follow the same steps that we did before, which would be to combine like terms. And on the right-hand side of the equal sign, I'm going to combine negative 30 and 4 to get negative 26. And then that negative 5p, I'm just going to write it down. Bring it down. And on the opposite side of the equal sign, I'm going to do the same thing. I'm going to combine my like terms. So I have 100 minus 11, or I could say negative 11 plus 100, whatever's easier for you. That would give me 89. And then don't forget to bring down your 10p. From there, we're trying to isolate, that is our ultimate goal, is to isolate the variable. So what is the inverse of subtracting 5p? It would be to add 5p. So I'm going to add 5p to both sides of the equal sign. 5p, 5p, and try to combine those like terms. On the right-hand side, they would cancel, and that's really good. That's what we want it to do. And I would have 15p plus 89 equals negative 26. So look at where we're at now. Ultimately, we want to get 15p alone. So the inverse of adding 89 is to subtract 89. Let's go ahead and do that. So I would get negative 115 is equal to what? 15p. We always just have to bring it down. To the opposite of multiplying by 15 is to divide by 15, and that's our ultimate goal, is to get our variable alone. P is equal to negative 115 over 15. But if I notice one thing about this fraction, it's that both of them end with 5 on the numerator and denominator. Whenever that happens, I know I can reduce this by 5. That's the bill. You'll get used to that. So if I reduce this by 5, divide by 5 on top, divide by 5 on bottom. My pen is having a moment here. Divide by 5 on the top and bottom. Then I'll be left with negative 23 on the top and then 3 on bottom. You're in Algebra 2. Do not be panicked if you get an answer like this that is an improper fraction. That is perfectly normal and it's okay. We're going to go ahead and move on to example 3. For this one, we're going to solve what's called a literal equation. And for a literal equation, notice there's no numbers involved, it's just variables. And we're going to try to solve for y. Solve or isolate. Isolate y. So in order to do that, what I like to do is to look at this and find y. And you can box it if you want, or you don't have to. But I like to look at y and say, okay, what am I doing to y? Let's make a list. What am I doing to y? Starting with the thing that's closest. And what is closest is adding that x. So what's happening to y? I'm adding x to it. And then what else? I'm dividing by z. And then what else? I'm subtracting a. That's what I'm doing to y. I'm adding x, dividing by z, and subtracting a. So how do I undo that? This is what I'm doing. How do I undo it? In order to undo it, we're going to use inverse operations. The inverse of subtracting is to add. So I'm going to add a. The inverse of dividing by z is to multiply by z. And then finally, the inverse of adding x is to subtract x. So this is what I call a do-undo chart. So in order to undo, or to get y alone, to isolate it, what I'm going to do is undo what's happening. So I'm starting from the bottom when I'm figuring that out. I'm going to start by adding a to both sides of the equal sign. Add a to both sides. And let's see what we have. We have x plus y over z. These would cancel because they're inverses. Equals a plus b. If I put b plus a, it means the same thing. I would be fine. So I did add a. Next, I need to multiply by z. let's see, I'm going to take this side, everything that's on this side, and I'm going to multiply it by z. And I'm going to take everything on this side, and I'm going to multiply it by z. Inverses cancel each other, so multiplying by z and dividing by z makes that cancel. And then my z is just on the opposite side now. So I have x plus y is equal to z times a plus b. Could I leave the z at the back? Yes, I could. But if I multiply, it's the same as if I put it in the front or the back. So now I've multiplied by z. What's the last thing we do? Subtract x on both sides of the equal sign. Subtract x. So it would cancel here, and I'm left with y equals z times a plus b minus x. There you go. We're going to do one last example. In this last example, notice it's a formula for the area of a trapezoid. A is 1/2 h times b1 plus b2, where h represents the height, b1 and b2 are the bases. If you need to draw a quick sketch, you can. I'm not a geometry teacher, so sorry for the look of that trapezoid. So the height would be here, h, and the base 1 would be this length here, and base 2 would be this length down here. You can use that information, but in reality, what is the question asking? It's just asking us to solve for B2. So I'm going to look at the formula. And I'm going to make my do-undo chart. What am I doing to B2 right now? First thing I see is B2 is right here. What am I doing to it? I am adding B1. And then let's move outside the parentheses. I'm multiplying by h, and I'm multiplying by 1/2. That's what I'm doing. So how do I undo that? Inverse operations. What's the inverse of multiplying by 1/2? You have to remember that the inverse of a fraction is its reciprocal. So reciprocal means flip that fraction. Multiply by 2 over 1, or I could just say multiply by 2. What's the opposite of multiplying by h? Is to divide by h. And what's the opposite of adding b1? Is to subtract b1. So let's do those steps. First one, I'm going to start from the bottom and work my way up. So I'm going to multiply both sides by 2. I'm going to multiply this a by 2, and I'm going to multiply this whole thing by 2, which is going to cancel out the 1/2. I'm left with 2a equals h times b1 plus b2. Next, I'm going to divide by h on both sides of the equal sign. Divide by h. So what am I left with? I have to remember, inverse operations cancel each other. 2a over h equals b1 plus b2. So I finished second step. Third step, how do I move the b1? I'm going to subtract it. So minus b1. I know it can be confusing because there's variables and no numbers involved, but if they are not like terms, you don't have to combine them together. So we actually have our answer here. b2 is equal to 2a over h minus b1. Thanks, guys.